Hey guys, this video is about the angle addition postulate. Just to kind of recap where we left off with our angle basics, an angle is two rays that have the same initial point. Here's our diagram here, and our two rays, you can see, have the same initial point there. The vertex of an angle is that initial point where the two rays meet. And then we have the sides of the angle, which I just highlighted here for you in yellow. Those are called the sides. And then interior would be like the inside of the angle. And then anything on the exterior would be on the outside of the angle. Let's say we have two angles that have the same measure. Those would be called congruent angles. Angles with the same measure. So to give you an example of what this would look like, I'm going to quickly draw two angles. I'm going to label them 34 degrees. So we'll call this one CAT. DOG, cat and dog, and they're both 34 degrees. Another way that you may see two congruent angles being marked is with this symbol. And this is called an arc mark. And that denotes that the two angles are congruent. So you may see some notation that looks like this. The measure of angle CAT is equal to the measure of angle DOG. That's if I gave you the two, like 34 degree. If I gave you that information for both angles, you would use these symbols. If it has the arc mark, then you would simply say angle CAT is congruent to angle DOG. So that's if you see the arc. Adjacent angles, this is another important vocabulary word. Adjacent angles share a common vertex, but they have no common interior points. So an easy way to remember that is that there's no overlap, no common interior points. So an example of two adjacent angles would look something like this. So let's say this is angle ABC, and I have a second angle CBD. These two angles would be considered adjacent because of the common side that they share. And they share a common vertex. So, in short, adjacent angles are right next to each other. They're kind of smushed together, but there's no overlapping sections. Which leads us to the angle addition postulate, which kind of sounds like segment addition postulate. So you may remember from a previous video the SAP, which was for segments. The angle addition postulate, or AAP, is pretty much the exact same concept, but instead of dealing with segments, this is for angles. Okay, so I'm going to go ahead and draw a diagram first before we write out the whole postulate. Looks something like that. And we'll add 4 points. Q, R, S, T. So the angle addition postulate says that if a point, I'm going to call it S, is in the interior of angle QRT, that's the big angle here, which it is on the inside, the interior, then the measure of angle QRS plus the measure of angle TRS should be equal to the measure of angle QRT. So, long story short, if you have two adjacent angles, like we have here in this diagram, if you add their two measures, it will be equal to the total of the larger angle. which makes sense, right? So now let's say that angle QRS is 40 degrees and angle TRS is 83 degrees. If I wanted to know the measure of angle QRT, I would simply plug these into my angle addition postulate, or basically just add them together. For a total of 123 degrees. Go ahead and copy down examples 2 and 3, both of which we're going to use the diagram right here. So you want to make sure that you copy down this diagram and make sure you put the points in the correct locations. All right, let's do example 2 together. So first thing that we want to notice about this diagram is that there are some special symbols which we talked about at the start of this video. So if you don't remember, flip back to one more page of your notebook, and this arc mark right here told us that if you see two angles with arc marks, that means they're congruent. So that means they have the same measure. So I'm going to keep that in mind when I look at this diagram, that these two angles with the arc marks must have the same measure. Okay, so example 2 tells me JOL is 85 degrees and LOK is 37 degrees. So I'm trying to find angle LOM. So the first thing I'm going to do is label my 37 degrees here for angle LOK. And then JOL, which is the large angle here, JOL is 85 degrees. In order to find angle LOM, I need to also know angle JOK. Well, I can use the angle addition postulate because I know that JOK and LOK together make JOL. So step 1 is to write out our angle addition postulate like we did above. So I'm going to do the measure of angle JOK plus the measure of angle LOK equals the measure of angle JOL. Now, you may be looking at this saying, but Mrs. Murray, angle LOM is nowhere in that angle addition postulate equation. Yes, you're right, but keep in mind, LOM and JOK are the same. So really, this is the same as angle LOM, right? So the measure of angle LOM and JOK are congruent, plus LOK we know is 37, and JOL is also given to us as 85 degrees. So basically we're just needing to subtract 85 minus 37 for a final answer of 48 degrees. So the measure of angle LOM equals 48 degrees. Okay, now I know most of you probably could have looked at this and just typed on your calculator 85 minus 37, that gives me 48. This one's also 48, done. It's going to be really, really imperative that you write out an equation to represent your problem, because later on when we get into the algebraic problems, it's not going to be as easy to do in your head. Okay, let's try example 3. Example 3 is different numbers, so we want to clear this off. Let's see what we have now. So we have JOK is 50 degrees, JOK right here. LOK is 32 degrees this time. Find the measure of JOM. Okay, so this one is kind of like example 1, where we're adding smaller pieces to get a total, but now I'm adding 3 angles. So first thing we want to keep in mind, if this is 50 degrees, this is also 50 degrees, right? So I'm going to simply add all 3 of these small angles. So LOK plus the measure of LOM It's going to give me the whole thing, JOM. Now we plug and chug. So 50 plus 32 plus another 50 is going to give me my final answer. So the measure of angle JOM is 132 degrees. Make sure you put a label on there. Alright, same diagram, new question. Example 4. If the measure of angle JOK is 3x plus 1, the measure of angle JOM is 110 degrees, and the measure of angle LOK is x plus 10, find the value of x. Okay, so it is absolutely imperative that we set up an equation to represent these expressions. So first I'm going to take these expressions and label them on my diagram. So this is 3x plus 1. LOK is x plus 10. And JOM, the entire thing here, is the 110 degrees. So I'm going to use the same equation that I had set up from example 3. So measure of angle JOK plus measure of angle LOK plus LOM, which we don't know what it is right now, but all three of those angles together equal the measure of angle JOM. Alright, plug in what we do know. So I know JOK is 3x plus 1. I know LOK is x plus 10. What do we know about LOM? It's the same thing we knew about LOM in the last couple examples. Because of this arc mark, right? Arc mark means congruent angles. So if this is 3x plus 1 and this has an arc mark, it's also 3x plus 1. So I can plug in another 3x plus 1 for LOM. Now we can combine like terms. So I've got 3, 6, 7x, 10, 11, 12. I also know that JOM is 110 degrees, so I can plug that in too. Subtracting 12 from both sides, so I get 98 divided by 7 to get our final answer for x, which is 14. No degree symbol because x does not represent an angle measure. It just represents a missing value. Last problem that we're going to do together. So this is an application problem. Each eye of a horse wearing blinkers has an angle of vision that measures 100 degrees. The angle of vision that is seen by both eyes is 60 degrees. Find the angle of vision seen by the left eye alone. So in order to solve this problem, we need to set up some type of a diagram to go along with this word problem. In case you don't know what horse blinkers are, it's these little things that block the horse's vision when they're racing so they don't get distracted. So here's a diagram that may help you visualize this. So both eyes have a span of 100 degrees that they are able to see, but don't forget there's a section where both eyes overlap and they can see the same thing right in front of them. So that would be section 2. That's the angle of vision that's seen by both eyes, which they tell us is 60 degrees. Each eye can see a total of 100, so that means angle 1 and 2 together is going to be 100 degrees. Likewise, angle 3 and angle 2 together are going to be 100 degrees. So now we have a diagram that looks somewhat like this. So remember, section 2 was the 60-degree section. Each eye, so the left eye can see 100 degrees, and the right eye can also see 100 degrees. So that leaves 40 degrees on each section remaining, because these two have to total to 100. Those also need to total to 100. So if the question is, find the angle of vision seen by the left eye alone. That means pretty much angle 1, because we don't want the overlap of the right angle. So that section would be a total of 40 degrees. Oops. Since it doesn't have a name, we could just say left equals 40 degrees. Or you could say measure of angle 1 equals 40 degrees, since we named it angle 1.